In this video, we're going to be talking about polar coordinates, and polar coordinates is definitely a topic that gives plenty of students trouble, whether you're in usually pre-calculus when you first start to see this, or calculus 2 when it comes back to bite you. It's definitely a topic that confuses a lot of students because it's so different than what we normally work with. What we normally work with, it's when we're dealing with, let's say, just regular functions, like f of x uh, equals x or something like that, you know, we're dealing with the rectangular coordinate system or the Cartesian coordinates on the Cartesian plane. The Cartesian plane is just an xy axis, and it's called the rectangular coordinate system because, if I were to define a point or something like that, you always define, an x value, how far out you go and how far up you go. And you do that and you pretty much you always get a rectangle every result you get. I could pick, x equals like 10 or something and y equals 1, then it'd be like that. You always get a rectangle, hence the rectangular coordinate system. But what really changes up the game is the polar coordinate system, where you're no longer defining things in terms of rectangles, how far out, how far up. You're what you're really doing is you're defining things based on how far away they are from the origin and what the angle is really between your basically your terminal side and the axis. So polar coordinates will usually rely like this. They'll make triangles in the long run, and they have theta, just an angle, and r. And when you graph these guys, the graph you're going to draw is very different. You're not going to be drawing an XY axis. You're not going to be drawing an XY axis anymore. You're going to be drawing a whole different type of graph for the polar coordinate system. And I'm going to just paste a pretty good sketch I found online in here. It would take me forever to draw this, and I imagine when you take your test 2 or something, um, it'll be given to you like this because just drawing this takes a really long time. So you can see that what you're given is you're giving just a bunch of concentric circles, one circle, one circle, one circle, and then you're given basically just the angles. And so what you're going to see is that points, they're no longer defined as xy values. They're defined as basically how many circles out you go and what angle you're going to have. So let's just kind of jump into some examples right here, and hopefully it'll make some more sense. And I'm going to leave this in here because we're going to start just by simply graphing some points. So off to the side, off to the left over here, I'm just gonna write 1 comma pi over 4. And one thing about polar coordinates is that you have to be very comfortable with trigonometry. This means being able to jump back and forth between degrees and radians or radians to degrees and so on and so forth. So you have to be pretty comfortable with this. If not, I advise you to look over your notes and familiarize yourself with this. So I know that pi over 4 is the same thing as 45 degrees. So what I'm going to do, is I'm just going to, over here, I'm going to kind of label how polar coordinates are set up. It's always r and then theta. If we had rectangular coordinates as x and y, but for polar coordinates, it's r and theta. So, here 1 is my r and pi over 4 is my theta. So what I'm going to do is I'm going to put a point there. I'm just going to put a point there. So a good analogy for this, and one my professor told me when I was first learning this, is that basically you want to imagine that pi over 4, that's basically like, you could imagine it's like sonar or something. You constantly have this little loop going around, going around, going around, and you have to tell this little line where to stop. Well, I want basically it to stop at 45 degrees or pi over 4. That's where I want it to target. I want to target pi over 4. I want to target this guy. And then we have to ask ourselves the question, well, how far out do we need to go? How far out do we need to, how many circles out do we need to put this point? Well, I know that I'm going to be at pi over 4 degrees, which is 45 degrees. So then I just have to see, well, how many circles out am I going? Well, the answer is just one. one circle out. And R is basically just determines how many circles out you go. So that means I would just put my point right here, right there. And I'm just going to call this point A over here. Point A. Point A. And that's it. And so really what you want to do is you just want to say, what angle am I targeting? So you get the angle you target, 45 degrees, and then you could even imagine like, hey, you have this little ant. You have this little ant, and you want to tell him, hey, how far out are you going to go? Well, I'm going to tell my little ant to go 1 unit out. So I'm going to say, hey, little ant, you're targeting 45 degrees, and you're going 1 unit out. And that's it. That's all there is to it. So let's try another example. Let's just try another example. Let's say I had -2 and 3 pi over 2. So this one's a little different because I'm working with negative angles now, but it's really nothing we can't handle. So 3 pi over 2, I recognize that that is the same exact thing as just, 270 degrees, 270 degrees. So I'm just going to say it's 270 degrees. And sorry, let me put a theta right there as well. So this is 270 degrees, and remember this is my r and this is my theta. So I'm gonna tell my ant like, hey, target at 270 degrees, targeting here. How far out do you need to go? Well, I'm not gonna go too out, because there's a negative out front. So when there's a negative, I'm gonna tell this little ant to not go forward, but he's gonna go backwards too. So he's targeting here, but he's not gonna go here. He's gonna go backwards too. So instead of being plotted all the way at 270 degrees, he's actually just going to go in the opposite direction. So he's just going to go here, right there. And I'll call this point B. Point B. Point B. There we go. So it's not too bad at all. It's really, really a simple process. So next thing we want to do is let's just graph another point. So 3 and -pi over 3. And again, before I move on to this guy, just always remember that if you have a negative radius, you just go backwards. You would still target the same angle, but instead of going forwards, you would just go backwards in the reverse direction. And that's all there is. It's not as complicated as it looks. So now what we're going to do is we basically just want to graph this other point, 3 -pi over 3. So again, you have to be really comfortable with your trig. Here. So, I recognize that -pi over 3, that's the same thing as 300 degrees. So I'm going to tell the little ant, hey, you're targeting over here at 300 degrees, and he's going to be going 3 units out. So targeting 300 degrees, targeting this, and he's going to go 3 units out. 1, 2, 3, right here. Just 3 circles out. And I'll call that point C. And that's all there is. That's all there is for graphing these guys. And one more thing before we move on is that I want you to know that there's multiple ways to basically write these coordinates. In other words, I see 1 comma pi over 4, but what I'm really trying to stress here is that there's multiple ways to write the same point. In fact, there's tons of ways to write the same point, and I'll show you what I mean here. Let's say that I want to plot point A again. I'll just work with point A. And we know that A is 1 comma pi over 4, and we already graphed that. Over there. But is there a different representation of it? Is there a different way I can do that? And the answer is yes. There's plenty of different ways you could do this. And what if I told you that another way of writing this was -1 comma 5 pi over 4? So let's think about that. Well, 5 pi over 4, we know that that's 225 degrees. It's 180 degrees more than this angle right here. So okay, so I'd be right here. I'd be right over here. But I'm not going to go 1 out because there's a -1, so I'd go 1 backwards. I'd go one backwards, so I'd just travel to here, and I'd be at the same point again. So there's multiple ways to write the same point. One technique to do that is you could add pi to your angle and then reverse the signs. That's always a great way to get the same a different representation for the same point. Usually books will ask you to do this. They'll ask you to say, hey, they'll say, hey, write this point in usually 2 or 3 different ways. So, let's think of another one. Let's just think of another representation we can do this in. Okay, well, I see, let's just use 1 again. Let's use 1. Let's just use 1. 1. And let's think of another angle. So we don't want to use pi over 4 again. We just want another angle that would mean the same thing. And a coterminal angle, a point that ends at the same place, would just be 9 pi over 4. We just add 2 pi to it. We just add 2 pi to pi over 4, and we get 9 pi over 4. So, that works great. I can just put A would go in the same exact place. I go 1 out, and we know that 9 pi over 4 is going to end up at 45 degrees again. It's going to end up the same place, so it's just right there. So, there's plenty of different ways to write the same thing. Really don't let it confuse you. Sometimes your answers will be different than what's in the book. But it's really all the same. So let's just try to convert one more point C, and just find some more representations of it. So point C. Okay, well, let's just convert that. I'm going to skip point B because, there's really not a need for this many examples for something like this. So we knew that C was 3 comma negative pi over 3. It was 3 comma negative pi over 3. It was right over here. So what if I could find an angle that was, well, just a point, a point that's the same, gives me the same point? Okay, well, let's think about that. So what I could do is I could simply just, add 180 to my angle and, add pi to the angle and reverse the sign. So I'd have negative 3. And then we just want to say, hey, well, what's negative pi over 3 plus just pi? And what's negative pi over 3 but just pi? And then it's just 2 pi over 3. 2 pi over 3. And, we could even check that. Because I know for a fact that 2 pi over 3 is the same thing as 120 degrees. 120 degrees. And we would be going 3 units backwards. So 120 degrees, I wouldn't go here, I'd just go 3 units backwards like this. And I'd be at the same point again. So let's do just one more different way of representing this, and we should be good. It's definitely something that's not too hard. So let's try just 3 again. And we don't even have to use the negative representation of this angle. This is just 300 degrees. So why don't we just use 300 degrees as an angle? There's no crime against it. So we'll just use 5 pi over 3, which is just 300 degrees. So if I go 3 units out, and I'm targeting 300 degrees, I would end up at point C again. So, it's a very simple process in plotting these points. Usually when you work with polar coordinates and such later on, in higher math, you usually go on to graph things such as transversal circles and cardioids. But graphing these, it's really just a walk in the park, and it's a really simple process. In order to make this video not too long, I'm just going to split this video up into multiple parts. And in the next video, I'm going to be switching between polar and rectangular forms, polar and Cartesian equations. I don't want to do it all in one video, otherwise this video would be like 30-40 minutes or something, and that's just, I want to make these videos pretty bite-sized. I don't want to just throw all of this information on you at once. So this is really just how to graph these points. Again, just practice doing it. Usually on a test or in homework, you'll be given this plane right here, this polar coordinate system, and it's really just quite simple. And always just remember that the points you're given, it's always just r and theta, r and theta. R represents how many units you're going out. Theta is just that angle you're targeting. That's all it is. If your r is negative, you're not going to go, you're not going to go forward that many units. Your little ant is going to go backwards that many units. And that's all there is to it. So, word of advice, just make sure you're really comfortable with your trigonometry and where all of the degrees or radians are on your circle, and you should be fine. It's a really easy section, and it's really just free points if you know how to do it on a test. So stick around and I'll upload another video on polar coordinates in just a few minutes. Thanks.